Hi, so today we're going to be talking about inverse derivatives. And the first question you might have is, what is an inverse derivative? Well, that's pretty self-explanatory. The inverse derivative is just the derivative of the inverse of any given function. But first, since we're talking about inverses, let's review what inverse functions are. An inverse function is sort of like an undo button that reverses a function. For example, if f of x is equal to y, then the f inverse of y would be equal to x. Also, if f of 3 is equal to 5, then the f inverse of 5 would be equal to 3. And if your test allows it, you can also find the inverse of a function on a graphing calculator. Here I'll show you how to do it on a TI-84 Plus. To do this, first enter a function, then you can graph it, then quit to home screen. Press the draw button and select draw inverse. Then press alpha trace and choose the function and press enter. Now back to inverse derivatives. One way of finding the inverse derivative would be making a graph. First, graph the function of f of x, shown here in red. Then you find the inverse function by inverting it over the line of y equals x. Inverse function here is shown in green. Then by using the slope of the inverse function of f of x, you can estimate the derivative of the inverse function of f of x, shown here by the pink graph. But what if you're like me and too lazy to do all that graphing and reflecting? Well, then we can also figure it out mathematically. We can find the inverse derivatives by using an equation, which is 1 over f prime of f inverse of x. There's really no way around it, you just gotta memorize this equation, as you will see in the practice problems we do next. There are 3 steps to finding the inverse derivative of a function, and I'll walk you through those 3 steps as we do the next problem together. So let's try to find the inverse derivative of f of x is equal to 3x squared plus 11x plus 7 at x equals to 1. Step 1. At the inverse of f of x, f of y is equal to x, and in this case, x is equal to 1, so we solve for x when y is equal to 1. We can solve this using algebra, and eventually we'll get x is equal to negative 3 or negative 2 over 3. Step 2 is to find the derivative of the given function. And I'm just going to assume that you guys already know how to find a derivative of a function, and so the derivative of 3x squared plus 11x plus 7 will be equal to 6x plus 11. And now the third and final step would just be to solve using the equation that I gave you earlier. And since we're told to find the inverse derivative when x is equal to 1, we plug in 1 for x and we solve. Remember that the derivative of f of x is 6x plus 11, and the f inverse of 1 is negative 3 or negative 2/3. Now we can solve for 1 over f prime of negative 3 or 1 over f prime of negative 2/3, and we get plus or minus 1 over 7. And that is our inverse derivative when x is equal to 1 for the function of f of x is equal to 3x squared plus 11x plus 7. We can also use these steps to solve for the inverse derivative of trig functions. I know that might sound scary, but don't worry, it's actually really easy and we can do a problem together to prove that. So let's find the inverse derivative of f of x is equal to 7x plus sine 2x when x is equal to 0. If you'd like, you can pause this video right now to do this problem on your own and then come back and check your work to see if you've done it right. And we'll do the same steps as before, so we'll plug in 0 for the y. Solve that and we'll get that x is equal to 0. Continuing to step 2, we find f prime of x, or the derivative of the function, which is 7 plus 2 cosine of 2x. And on to step 3, we plug in everything into our handy dandy equation for x is equal to 0, and we solve, and finally we get the answer as 1 over 8. See, that wasn't so bad, it was pretty easy. And that's all I have on inverse derivatives, but if you want extra practice, you can go down in the link in the description of the video, and you can do extra practice. There is a key linked as well, and I hope you do well on your test.